All right, guys, welcome to FRQ Notes, Semester 2, Week 1, page 72 in your blue books. This is the first of two questions we'll go over in this little lesson here. So let's get to reading here. It says, hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup on this interval from 0 to 6 is given by this differentiable, that's an important word, function of C, where T is measured in minutes. Selected values of C or T are measured in ounces, are given in the table above. So why is differentiable an important phrase? Well, what we're going to do on part B here requires our function to be both differentiable and continuous. So if a function is differentiable, then it's also continuous. So let's go ahead and take a look at part B. Is there a time on the interval from 2 to 4 minutes at which C prime of T equals 2? Justify your answer. Now you might recall that we've seen two questions of this type in this class. Sometimes they have the prime and sometimes they don't. The ones that don't have the prime are the intermediate value theorem, but this one has a prime, so it's not going to be that. The ones with the primes are going to be the mean value theorem. And these ones are kind of formulaic. You can just kind of go about it in the same way every time. The first thing that we're going to do here is we're going to state that fact then. We're going to state that C is differentiable and continuous on the interval. Now you'll notice that I put little parentheses on the one that says differentiable, and I put brackets on the one that says continuous. That's typically how we want to do it. The next part of this is we're going to say, since C is differentiable on 0,6 and continuous on 0,6, that means there must be some T where C prime of T is equal to the value they give us. So I'll show you how to write that. We would say there must be some value T such that C prime of T is equal to, and then we just do the mean value theorem, which we've discussed in class. And you're just going to use the numbers they give you. Sometimes they'll make you look for the correct pair, but usually they just give them to you. So C of 4, we could see from the table, is 12.8. And C of 2, we could see from the table, is 8.8. 4 minus 2 on the bottom there is 2. So subtraction on the top is going to give me 4. Division by 2 is going to give me 2. And that's what they wanted us to prove. So there it is. So your entire answer would look like everything that I've got written here. I'll circle it. This is all the stuff you would need to include. Since C is differentiable and continuous, you'd have to make that statement there. There must be some value T such that this happens. So basically you need to show your work here at that point. All right, let's go ahead and take a look at how they would grade us here. Now you can see how they wrote their answer here on the left side, but I'm more concerned about the points. So basically you can see that they give 1 point for writing this out. And then this here, I would say that I would encourage you to use the wording I have, but you can compare how they talked about using the MVT over here to what I wrote. But there you guys have it. Let's go ahead and take a look at our second one here. All right, so for this one, I'll go ahead and read the little word problem here. First, it says train A runs back and forth on an east and west section of a railroad track. Train A's velocity, measured in meters per minute, is given by the differentiable function v sub A of t. Notice it's differentiable once again. We're looking at meters per second, meters per minute, where t is measured in minutes. And they've got selected values of v over here given in the table. So what this means is that t equals 0, the train's velocity is 0, but after 2 minutes, the train is now going 100 meters per minute, and after 5 seconds, it's slowing down apparently to be going only 40 meters per minute, and by the time we get to 8 minutes, now the train is going negative 120 meters per minute. Now what does that mean? Remember, for positive values of v, that means the train is moving to the right. Remember, when velocity is positive, that means you're moving up or right, depending on what kind of an axis you're moving on. In this case, we're moving on a horizontal axis, so that means we're moving to the right. And then negative would mean we're moving to the left. So the train at some point from here to here started going from left to right. So, do the data in the table support the conclusion that train A's velocity is at negative 100 meters per minute at some time on the interval from 5 to 8? Give a reason for your answer. Okay, so notice this one's asking about train A's velocity, and that's what this is. So I'm just going to put that little symbol there. Now notice it's not a prime, okay? It's just this value is the same value they give us in the table. So we're not trying to find the derivative of the value in the table here. We're just trying to use the numbers that they give us. In that case, that means we're going to be using the IVT, which is an old theorem that we talked about a little while ago. All right. So whenever you do the IVT, the first thing you want to do is you want to make sure it's continuous. Is this function continuous? Well, yes, it's continuous because it's differentiable. And anytime a function is differentiable, it's continuous. All right, so that's done. The next thing that we want to do is we want to make sure that on the interval from 5 to 8, it actually does cross negative 100. Well, if I'm going from 40 to negative 120, and it's continuous, that means there's no holes or gaps. Would I have to at some point be negative 100? Yeah, of course you would. You couldn't get from a positive 40 to a negative 120 without crossing a value of negative 100. So the answer is yes. So now how do we word our answer? And here's how you'd write it. Since the function is continuous on the and goes from 40 to negative 120 on the interval from 5 to 8, there must be some value such that v sub a of t equals negative 100. So you need these 4 underlined parts, and this is the wording I've always recommended for these types of problems. So that's that. So I'm going to go ahead and leave the rest to you guys. You guys got your practice to do. Hopefully that was helpful, and we'll see you guys in class.